Ladies and gentlemen, thank you for joining me today on J Slay Made in the USA, where we explore truth, expose deception, and inspire courage. You know, guys, on this show, often we talk about the enemies that we can see, the dangers that are in front of our face. You could turn on the news, you can see it there. Heck, you can walk outside and often find, something wrong in the world that needs to be addressed, needs to be looked at. But what about the invisible? And I don't mean on a spiritual level necessarily. We do talk about that on this show, but on a chemical level, the things that are filling up our bodies and in the household goods that are around us all the time, our electronics, nonstick skillets, even just things you would never expect to potentially be problematic on a health level. Really are. And how do we navigate that? How do we try to stay away and averse to it as much as possible? I'm not an expert on that. That's why I brought on my guest today, which I'm honored to have her. It's Linda Birnbaum, Dr. Linda Birnbaum, who her bio is fantastic. She's an American toxicologist who's been sounding the alarms about endocrine disrupting chemicals like atrazine and PFAS, which has been harming our health for the last few decades. She was previously the director of the National Institute for Environmental Health Sciences at the NIH, and is currently an adjunct professor at the University of North Carolina, Chapel Hill. I could go on and on. I'm going to stop right there. Linda, thanks so much for coming on today.
My pleasure to be here, Jeremy. I hope I can be helpful.
Well, I know that you will be. And, I run a program for men called Warrior Mind, Body, and Soul. And like I said, I'm not an expert when it comes to this stuff. I can help a man get in shape. I can look at someone's habits, their sleep, things like that. But when it comes to these chemicals, the ultra small, you got to have a microscope. It probably can't even see it there. These things are around all the time. And, what do we do? How do we navigate it? And I'd like to start with the history. So in this country, I've heard you talk before on other podcasts about the 40s and 50s and major companies like DuPont. And by the way, I've been on their roof. I used to be a roofing salesman. There's a massive DuPont plant right outside of Nashville. And man, there's smokestack, there's chemicals coming out. So give us a little rundown, 10,000 foot level of the history of some of these chemicals that are bad for us on the day to day.
Well, there are many chemicals that may be bad for us. The question really is what do we get exposed to all the time? And so if you think back to the 30s and 40s and 50s, especially I'd say, during World War II, there was a tremendous push to develop new approaches, new ways of doing things, often focused on maybe into the military arena. But many of those things then turned out to have useful properties. So something like the PFAS, which is a horrendous name for more than 12 to 14, maybe 15,000 different chemicals. And what it stands for is per and polyfluoroalkyl substances. The important thing to know about these chemicals, they all have bonds between carbon atoms and fluorine atoms.
Okay.
That bond basically does not occur naturally. And it is a really strong chemical bond, which means that if you make it, you have a really hard time getting rid of it.
That's why they're called forever chemicals, right?
That is why they are called forever chemicals, because they are all environmentally forever. And many of them have very long half-lives in our bodies. And what that means, if you're exposed today, a year from now, 2 years from now, you still got most of it in your body that you were exposed to a year or two ago. And if you were exposed yesterday and today, then you have essentially double the amount.
So these bioaccumulate, if that's the right way to say it.
That is the correct way. Bioaccumulate means that it will accumulate in your body. So it leads to biological persistence. Now, there are some PFAS that don't hang around in our bodies very long, although even some of those that don't hang around so long in our bodies are still, if it was a drug, you would say, oh, that's a long time.
Right. So what would be the major companies? You mentioned kind of the World War II era. I mentioned DuPont earlier. I've heard you say 3M before. Would those be the two biggies, or would there be others that were involved in creating these chemicals?
Well, if we're talking about this huge family called PFAS,
Yes.
3M and DuPont were the major producers in this country, starting Well, it first made at DuPont, I think, by a chemist in the 30s, and then really everything began to ramp up in the 50s. There are other companies now as well that have jumped in, making kind of newer versions of PFAS. And DuPont, I mean, 3M actually, it's very interesting. In last year, just about a little over a year ago, they announced that by the end of 2025, they were going out of the PFAS business. They were no longer going to make any. They were no longer going to use any. DuPont, in I think it was about 2009, spun off their PFAS business to a new company called Chemours.
Okay.
And there's a large Chemours plant not far from where I live in North Carolina, which has led to contamination of the drinking water supply for over 500,000 North Carolinians.
Wow. Do you see that as a realistic goal for a company like 3M that's relied on these chemicals for so long? I mean, 2025 is next year. How's that possible?
Well, the answer is I think they had already in 1998, and then by 2002, they stopped making one of the most well-known and most concerning PFAS, something called PFOS.
Okay.
And they began to decrease that. And 3M makes lots of other things. So
Right.
they ended up saying this is a relatively, today, unlike say 30 or 40 years ago, is a relatively small part of their portfolio. And I think as the concern has grown about some of these chemicals, it's probably not the best financial place
Right.
for them to be.
Right. The PR gets in the way of the greed. At some point, those things, cross over.
Well, let's not call it the PR. Let's say the science, what we learn
Science.
about the health effects. The fact that we have information now. The CDC just recently recommended about people getting their blood tested for these chemicals. Something they said, if you live near a production facility or a place where these chemicals are used in production of something else, or if there's information that that tells you that like your water supply is contaminated or something, then you might not want to know what levels are in your body so that you can be followed for some of the health effects that have been quite strongly associated with exposure to this family of chemicals.
Let's talk about that exposure, what that really does. I can say all day long it's an endocrine disruptor, or it might affect your testosterone or your sleep. I can't really break that down. Can you go over generally? I know there's probably thousands of effects that it could or couldn't have. What are the big ones that we would see, average American family that hasn't been paying attention to this, but we're just taking in the big company products all the time? What are we going to see?
Well, that is the issue, Jeremy. That's hard. This isn't like an infectious agent where you got COVID, you got sick, you cleared the virus, and then you felt better. With many of these chemicals, what it does is puts you in more of an at-risk situation, increases the likelihood that you may get some health condition which you might not have had if you weren't exposed. But it's very hard to prove that your exposure specifically caused it to an individual. It's really a public health issue, and it's a statistical issue. So, for example, Jeremy, I can't look at you and say, hey, Jeremy, if when you were little, you had a little less blood lead, you would have had 5 more IQ points.
Yeah.
I can't, but I can look at a population and I can look at the distribution of IQ in the population and look at the lead levels. And you can see that there's a shift, putting more people in an at-risk category of, say, at risk of lower learning ability than if they hadn't had. But it's hard to do it with an individual. But if you are asking me, what are some of the effects that have been associated with PFAS in many, many studies? And I should say, almost all the effects that we've seen in people, we've also seen either in domestic animals, wildlife, or our experimental laboratory animals. So we have a biological plausibility for what we see in people. And so some of the effects that we do see endocrine disruption. We see effects on thyroid, and we're also seeing effects as we learn more, we see some effects on estrogens and androgens, our female and our male hormones, among others. We see effects on cholesterol levels. So higher levels of PFAS are often associated with higher low density cholesterol, which is the bad kind of cholesterol. You see that increase. We see other effects on the liver, on liver function. We see effects on the kidney. And this is, we see non-cancer effects on the kidney, but there's also some of the strongest data for the carcinogenic ability of PFAS are the results with kidney cancer.
Okay.
And we do see an increased risk of kidney cancer, also an increased risk of testicular cancer. And testicular cancer is a cancer of young men. In other words, the men who get testicular cancer, most cancers are associated with older people, but testicular cancer is primarily in young men. And by young, I mean, let's say roughly 20 to 50, kind of that age range. And we do see that. There's suggestions of other kinds of cancer that increase. We see preterm birth and decreased fertility. We see hypertension during pregnancy, which is extremely dangerous for both the mother and the baby. We see an increased risk of that. One of the strongest things we see is effects on our immune systems. So there is a lot of data showing decreased vaccination success rate with exposure to these chemicals, and this has been seen both in children and in adults. We see but you kind of also have the other side of the immune system. You have suppression of the immune system with the lower vaccination rate, and there's beginning to be reports of more fevers, more hospitalizations of children with higher levels of these compounds. But then you also see an increase in autoimmunity. Now, autoimmunity, things like ulcerative colitis, which thank God is a pretty rare condition, but it's a pretty miserable one. And that's an autoimmune. And so, very honestly, I haven't found a system in our body that hasn't been reported in some studies, and in most cases, multiple studies, which can be impacted by PFAS. Now, we understand that people are differentially susceptible. Men and women can react very differently to the same kind of exposure. People of different ethnic backgrounds and different races can react very differently. We know, for example, the food that you eat may tremendously change how you respond to things. It may also change how much you're exposed to and things, but that's another example. So we know there's this whole, we almost call it a new organ in our body, the microbiome, which are all the, say, bacteria and viruses and fungi that live in us and on us. And we now understand, we used to think, oh my God, that's terrible. Why do we want them? But they're very important to our health. But we understand, like a vegetarian has a very different gut microbiome from somebody who eats lots of meat.
Right.
Well, we don't really know what that means down the road, but it does impact how you are going to respond to other kinds of things.
Is there almost a fog of war that is shielding these companies to a degree for decades, where the chemicals, whether it's from those products or maybe it's just the amount of distraction and screens that everybody's looking at, there's 100 things you could point at that say that we have a decrease in overall health or an increase in cancer, and they could almost say, well, it could be this, it could be that, and it's hard, like it's correlation is not causation. That sort of defense. Do they use that?
Of course, I think a lot of people use the idea, and it's true, correlation is not causation. But when you see associations repeatedly in different populations done by different investigators, different studies, when you see that you have, for example, similar findings in your experimental animal models where you know exactly what they were exposed to and how they were exposed,
okay.
When you see, for example, when you can get mechanistic understanding. In other words, so if we understand, for example, that elevated cholesterol is associated with an increased risk of heart disease, and we have some understanding of how that happens, then you can kind of back up and say, well, but when you see it again and again and again, it is likely causation. You're never, with an environmental chemical, you're never going to intentionally expose people to it.
Sure.
Right? You're never going to, yeah, right. But you're never going to do what you do with drugs, where you run controlled trials and you intentionally expose people to something. You're not going to do that with environmental chemicals. The only place that I know it's really been done is with air pollution, where people have been exposed intentionally to air pollution, usually at a level below the regulatory level, to see, can we see something at lower levels? But you're not going to do that with environmental chemicals, not today. I mean, if you go back,
I want to go back to that point. I may push back a little bit with some of the research I've done. We'll see. Let's go back real quick. So these companies back then, I'm not going to say like DuPont, for instance, or 3M back in the 40s, 50s, 60s, as they're developing these things, they have chemists, they have scientists. They don't want to harm the public on purpose. Now they do want to make money, right? Were there people within those companies that would have been aware that these adverse effects were probably going to happen?
So the answer is yes. And there's actually, in some of the, there is evidence when people can get into the archives from these companies, whether it's via litigation or it's just via release of information, they can see that there were scientists who were raising an alarm in the past.
Okay.
But I think with the PFAS, we need to step back and say, PFAS are really useful chemicals. That's why we have them. People like, for example, their rain gear to be total water repellent. They like their nonstick, Teflon pans so that they didn't have to scrub with stainless steel wool or something. People like those things. People like, everybody loves their smartphone and their computer screen and so on. But I think we need to, when we understand that these compounds have the potential to harm our health, we need to step back and start asking the questions, the kind of questions that were asked with the ozone hole and the Montreal Protocol, where you ask the questions of what we call essentiality. And you say, do I really need that? And I'll tell you, I don't need my hiking boots to be totally waterproof.
Right.
And there are ways that I can make them water resistant that don't involve these chemicals.
Well, if these major companies are profitable in the EU, because that's a large market. I don't know how to compare to the United States, but it's a large market. If they're profitable there, then they could be profitable here. There would just be a kind of a learning curve as they no longer use those chemicals.
Well, okay. So in the EU has different regulatory requirements than we do in the United States.
Right.
Okay. And one of the differences in the EU now, they have a program called REACH, where you have to really assess what is the potential harm from a chemical, more like you do with pharmaceuticals, where they have to be tested for safety before they can go on the market. And in our country, the way that chemicals are treated is they're safe until proven. They're assumed safe. It's kind of like, the judicial system, assumed innocent until proven guilty. And that means that chemicals can get on the market without clear evidence of lack of harm. And I think that's why there are many compounds or many kinds of chemicals which are restricted in Europe more than they may be in the US.
Okay, that makes sense. So when you say PFAS in general, and I brought up a chemical called atrazine earlier, does that fall into the PFAS category?
No. Atrazine is a kind of pesticide. Now I'm trying to remember, is it pesticide or herbicide? I can't say I'm an expert in atrazine.
Well, I know that it's both. I've looked up the companies that use it, like Syngenta and others, and it goes into both of those products.
Okay, so it is not a PFAS. It has, as far as I know, it doesn't have fluorine in it. There are a significant number of pesticides which are PFAS. There are significant numbers of pharmaceuticals that are PFAS. And that's why I was starting to explain this issue of essentiality. So if you don't really need something, if it's not really essential, you stop using it.
Right.
If it's something that's really essential, but in fact you have a safer alternative, let's switch to the safer alternative. And
Sure.
if it's something that's really essential, but there is no, at this point in time, safe alternative, then you keep using it until you can find a safe alternative. And I should say a safe alternative sometimes doesn't just mean substituting another chemical. Sometimes it means you can have a different process, a different way of making something,
Sure.
So I think that that's something that we have to think about. We have a whole history of, it's going to be a terrible analogy, but jumping from the frying pan into the fire,
Right.
where you have a chemical that is bad, and then you switch to another one, and oh my goodness, because we never tested it, it turns out to be worse.
Sure. Yeah. Got to be careful with that. So one of the
Right.
products that I did, I've heard about the nonstick skillets and about the waterproof, hiking boots and all those kind of things when I'm skipping the big one, the household cleaners, all of that. But the one that I'd not paid attention to was, the old iPhone or I guess other phones as well, that there are PFAS. Is that in the screen, in the glass screen?
My belief it is, and it's in some of the chips, some of the computer chips as well,
Okay.
require PFAS to be made. Now, I say require, but there was a paper that came out about 6 or 8 months ago from the University of Massachusetts at Lowell, where they had found a non-PFAS way to make the chips. Now, it might not work for all chips, but it doesn't have to be all or nothing. We can do things in a more gradual way
Mm-hmm.
where you get rid of the bad actors. And I give, for example, both DuPont and 3M some credit where they stopped making some of the PFAS that we know are bad. But there were 14,000 other ones that we don't have a lot of information on. When we start trying to run studies on those other ones, and we're never going to do all 14,000. I mean, it's just not going to happen.
Impossible.
And impossible. But what we find is they all do many of the same things. And every single one of them is not going to leave the environment easily, because since that bond doesn't occur in nature, there is no easy way to break it down. If you think of some of the old chemicals that were of concern, some of the old pesticides,
Mm-hmm.
there have been approaches that have used like microbes, different kinds of bacteria, say, to destroy PCBs or to get rid of some of them. We don't have microbes that I know of yet anyway that can destroy the PFAS.
Hmm.
So there are ways, at least on your laboratory bench, you can get rid of PFAS, but they are very high temperature,
Sure.
very strong acid or something. They're not something that you can take in the field. So for now, we do have ways you can remove PFAS from your drinking water. Now, I can't take the Cape Fear River system near me, and there's no way to decontaminate an entire river system, but I can have filters on my drinking water, to remove the PFAS from my drinking water. But then what do you do with the stuff you remove? Well, at this point in time, you tend to put it in a landfill. And we all know what happens with
Goes back,
landfills over
the
time.
runoff goes back to the drinking water, right?
Right. Or, we can put it in a super deep well. But again, over time, and there's a lot of work being done to try to understand how can we really totally get rid of PFAS. But I think we've really got to, again, bad analogy, turn off the tap.
Well,
We have to stop making so much of it.
Sure. Yes. Let's talk about the atrazine for a minute, because that's the one when I watched the End of Men documentary. With, Tucker Carlson, he interviewed you, and one of the things that fascinated me was this atrazine and the fact that it could turn male tadpoles into female tadpoles. I forget the name of the scientist. You told me off camera. What was his name again?
Tyrone Hayes. He's a professor at the University of California at Berkeley.
Okay, so Tyrone Hayes, I forget, but it was just some tiny amount, like 1/1,000,000th of the amount of water in a bucket, and he could turn 75 tadpoles into the opposite sex with just less than a drop. And that was incredible to me. And then they started doing human studies, and this does affect my day-to-day work with men. because they talk about being tired and having low testosterone, and asking me what they should do.
Mhm.
The question is more about the atrazine itself. According to Tyrone, this was a few years back. He said 80 million pounds of it is put on our athletic fields, on yards, on almost everything conceivable in the environment as a pesticide or a herbicide, and that does filter into the drinking water. So I wanted to hear from you, scientific perspective. What is that actually doing to sperm counts, testosterone, and otherwise in adult males?
Well, I don't think atrazine is the only bad actor in some of the
Okay.
chemicals. We know that, for example, certain phthalates, which are plasticizers and are used heavily like in plastic, they get into our food. There are many, many different things. And we know those can also, the term we use is demasculinize, um, where it actually impacts the developing system. So, um, and there are other chemicals that can do the same kind of thing. And I think it's important to realize it's not just one thing. If you're someone, maybe you're a farmer and you're using high levels of atrazine and your water is very heavily contaminated, that may be your driver. But we
Okay.
know, for example, that there are other kinds of chemicals that can do this. So I think the important thing is that since we don't test chemicals for safety before they get out on the market, we're learning about more and more chemicals which can in fact affect the male. Now, some
Can
of
you
them
can
are
you stop and say, I'm so sorry? Can you say it one more time, because
sure.
maybe I misheard. You said we don't test chemicals for safety before they go out in the market.
That is correct. Under the US testing system, chemicals, not drugs have to be tested,
Sure.
but most chemicals in general are assumed. It's like our judicial system, assumed innocent until proven guilty. So in other words, drugs can enter the market with almost no safety information required before they enter the market.
Hmm.
And I will say that the way we used to test chemicals, and some people still do test chemicals, doesn't ask the right questions. We know a lot more today than we did, say, 50 years ago, when certain studies were kind of established, and this is what you do. And for example, for male impacts on the developing male or on the adult male, nobody routinely tested for testosterone levels in adults. They were looking for, oh, do they have a testes? Do they have the organs? But they didn't ask the question, are they functioning? And we need to be asking those functional questions as well as the kind of structural questions. And then we also have learned, for example, that there are certain structural changes or structural differences which they're not dramatic, but they can have an impact. And especially, we're concerned about the whole population. And for some reason, some people are more susceptible or more sensitive than somebody else. We know, for example, Jeremy, that the developing organism, so the fetus, is extremely susceptible. We know the infant is very susceptible. A healthy young adult, not as susceptible. And that all makes sense, because when can you have the greatest impact? When your body is developing and changing.
Yes.
So,
And are
adolescence,
these permanent changes when the body's developing?
yes,
Wow.
yes. And that this is some of the thing about endocrine disruption that I think um, people don't always understand. In an adult, in a man, an adult man, for example, testosterone levels may fluctuate somewhat. Okay. And they may go up and they go down. And if they go down a little, well, you can take testosterone, um, use that topical gel to raise your levels or something. But during development, if you don't have the right amount of testosterone, you're not going to form the organs properly or the function of the organs properly. So I don't want to get too detailed, but
No, it's
um,
okay. I'm tracking.
okay. Well, there's something called the anogenital distance, which is the distance from like the base of the penis to the anus. Okay. And that tends to be, I'm going to get it backwards. Let's just say it's supposed to be longer
Further
in males.
apart, right? Further apart.
Yeah.
I
And I'm
remember this
getting,
because you were talking about this happening with alligators, I believe, as well, right?
well, right. We see, okay, that's, let's just say that length is very important for determining maleness. And if that's altered, then what we now know is in people, in men, as well as in animals, they have a lower sperm count,
Right.
poor sperm motility, and so on. So people used to say, "Oh, well, it's not. What's the meaning of having this different?" And the answer is, okay, there's a problem associated with it. But you were talking about alligators. I mean, that's kind of referring back to the work that was initially done by Lou Gillette, who passed away, unfortunately, way too early. But in general, when I see a chemical or a group of chemicals having effects in multiple vertebrate species, not only, rats and mice, but we see it in, say, reptiles, we see it in birds, we see it in amphibians, we see it in fish, and we see this in multiple species. Why would we think that some people might not have a similar response? So that we learn a lot by studying some of these different animal species. And Lou Gillette was a wonder there at showing the demasculinization of alligators. And that was related, we believe, to pesticides that were made on the shore of Lake Opopka. And, right now there's a scientist at North Carolina State University who is looking in the lower Cape Fear River with all the PFAS and showing that the alligators, who are more heavily exposed to the PFAS appear to be immunocompromised, and have other health effects. So, I think our wildlife studies, our domestic animals studies, never mind all our rats and mice and guinea pigs and monkeys studies, are very informative about what might happen to people.
Okay. And the effects of the lowered testosterone, the lower sperm count, and I'm just, bundling a bunch of things together here, the lower quality of the sperm, the demasculization, as you're talking about. Give me some of the actual practical daily effects that people would experience that have these issues.
Well, I think, for example, if a man has a lower sperm count, there's been a tremendous increase in subfertility and infertility in our population. Now, worldwide, certainly there are plenty of people around, but we know that sperm count, the data is quite conclusive now that over the past 50 or so years, sperm count is down by about 50%. And I remember talking to a colleague of mine who's a fertility specialist, because people in rats, you can have a 90% decrease in sperm count and they can still father pups.
Right.
But his comment was, in his population, a 50% decrease in sperm count means that there are a lot of men who become infertile.
Okay. So
Or
that's an
certainly
obvious
subfertile.
one. Subfertile,
So,
infertile. Go ahead. I'm sorry.
correct. I think that's a pretty serious one.
Yes.
When you alter the hormonal status, which affects development and then can also affect it, we know that can alter your susceptibility to other kinds of stresses that you might have, whether it's an increased risk of certain kinds of cancer or increased risk of certain kinds of mental conditions or health conditions. Our body is a pretty highly integrated organism, and you kind of push it one way or push part of it one way, it will have impacts the other way. And, we've talked about like the demasculinization, but I think it's important to realize that like things like phthalates also affect the female.
Okay.
And can affect the female. And we know that phthalates, for example, not only have these effects, on our sexual systems, but they affect learning and memory. So we know that, it's impacting IQ. I actually wrote a invited editorial a couple of years ago talking about that we needed to protect the brains of our children. But I think that we need to look more broadly. I think I'm trained as a toxicologist, and I think that in tox we've tried to look at one chemical, one effect, and we have to start looking more broadly and
Sure.
trying to understand that most chemicals do more than one thing. And what happens is a function of, well, does this occur during development, or is it only in adulthood? Does we used to think you'd see the same things in our males and females, and now we know, especially if it's an endocrine disrupting chemical, you can often get very opposite effects, which is interesting. So,
is brain fog? I hear that often from men that join the program. Now, part of it's just because maybe they're eating very poorly.
Lost your minute, Jeremy. You're very low.
What about now? Back?
Better.
Okay.
Yeah.
So brain fog, that comes up often when I'm talking to men, but men and women. Let's open it up. Do these chemicals, phthalates, PFAS, the atrazenes, endocrine disruptors, do they cause brain fog, or are they correlated with it?
Okay, so I know of associations with ADHD, for example. Now, I wouldn't call that brain fog.
It's different.
Um,
Yeah.
yeah, brain fog is kind of hard to define, at least for me. I know that many people who have chemotherapy complain of brain fog, but it's kind of, again, hard to define.
Well,
And
I
whether that,
associate it with a loss of energy, kind of like the late afternoon. Just everybody gets tired from time to time after lunch, but something deeper than that. I mean, it could just be a loss of testosterone to the point. I mean, there's like, as a younger man, full of libido and all this stuff, and then that goes away. You don't have that same kind of vigor maybe for your daily life.
Yeah, so I can't answer that question, Jeremy. I really don't know, but I certainly, as I've said, I think a lot of chemicals do things that we just don't even think about and don't even know about.
Okay.
And I think it's certainly, I don't know if anyone who's actually done a nice study where they would try to look at people who report brain fog and compare them to people who don't report brain fog. And you would want to have people of the same age and same, say, socioeconomic status. You'd want to control for things like race and ethnicity. And, you might be able to, and then you would say, take blood samples or urine samples and say, well, what are they being exposed to? And that would be, it's a difficult study, but it's something that could potentially be done that might shed some light on, is there something going on? I mean, again, I'm thinking of people who have chemo who report brain fog, and they also often are very, very tired.
Right.
And, that's because chemo is really poison. So
this is a total sidebar. We had a neighbor that just passed away due to cancer, breast and brain cancer, and a wonderful, wonderful woman. Went through the whole chemo process, traditional medicine. Do you have any advice for someone that is being, told it's time to, you need to...
Losing you again. Sorry, Jeremy.
Yeah, I don't know what's happening here. This question may be out of your spectrum, so it's okay if you don't answer. But what is your general feeling about chemotherapy when it comes to cancer?
Well, I think that chemo has come a long way. So we now have, first of all, if it's a choice between life and death, many people, at least at some point, will choose chemo. But chemo is becoming, some of it is much more specific. So there's this whole new approaches with what are called monoclonal antibodies, where they would specifically target the cancer cells. And that kind of therapy tends to have less global health effects than the kind which is just killing you.
Right.
And the hypothesis or the way much of chemo certainly has been, is that cancer cells grow more rapidly than most of our normal cells. So hopefully they'll die quicker, because dividing cells will be easier to kill than cells that aren't dividing or only dividing
Right.
infrequently.
Let's talk practically for a moment to the person that's listening, that where this is fairly new information to them. Maybe they knew about endocrine disruptors, but all these, it's like, wow, there's PFAS, there's the atrazine, there's the phthalates. How do I get away from this? What's some practical advice you give to someone that's just saying, I don't know where to start?
And it's a really hard thing, because it's very hard for an individual. I mean, if you ask me what I kind of do, the kinds of things I do, I mean, we got rid of our Teflon pans, and I use ceramic pans, which don't have PFAS on them. I don't buy things that are advertised as completely water repellent, or waterproof most of the time anymore, because I don't think it's that important. Makeup, for example, has had lots of PFAS in it. Some of the makeup that's labeled as waterproof makeup, I don't buy that kind of makeup anymore, just because, why take that chance? For some of the phthalates and stuff in plastic, one of the simplest things that people can do, and this is easy, don't heat your food in plastic.
Okay. Yeah, my wife
Because
got on me about that the other day.
don't do it. Put
Okay.
it in glass, put it on, on ceramic, put it on paper, but don't heat, because when the temperature goes up, chemicals move faster. And so they tend to move from the plastic into your food. So don't do that. Some people won't even store in plastic. I do, for me, I say, what's practical? What can I do that's easy?
Right.
So if I buy something and it's in plastic, I don't immediately take it out if it's going in the fridge. But as soon as I want to heat it up, I take it out of the plastic.
Now, if my wife watches this, she's going to get upset with me for asking, but we kind of poke at each other on these things, and I care about our home being healthy and making the best choices possible. But she's one, she'll buy, the say a cereal box, and then pour that cereal into a glass container to store it. And I'm thinking, well, it was in the plastic from the time it was in the factory to the time we got it home. Does that really make a difference there?
So there have been some studies that have been done, and it does make a difference. I don't do it just because
it's just
if I had
thing, right?
Yeah, if I had little kids around today, I might do it. But at this point, I figure I'm getting old, and I'm not as worried about that kind of thing. But I still wouldn't heat in plastic. And
Okay.
I think there are, I would love to see us as a civilization start really decreasing our use of plastic, because we now know, we all have seen the environmental plastic contamination on the side of the road and stuff.
Oh,
but
it's bad.
But now we're realizing that every one of us poops out a credit card's worth of plastic every week. That's kind of gross.
I'm going to start using that.
Okay.
You didn't trademark that, did you?
I did not. But, and there was recent papers showing about the nanoplastics, which are even tinier pieces of plastic, that they get into our body, they get into our blood, and they get into our organ systems.
So you're telling me what you just said is a credit card's worth of plastic is processed through my body and pooped out every week?
Correct. Yeah.
Is that, I'm not sitting down eating plastic purposely. You're saying it's leaching from?
Well, we know, like water bottles, plastic water bottles, have, can't remember if it was hundreds of thousands or millions of tiny particles of plastic that you're drinking all the time.
Okay.
So again, that's a whole nother topic. But the point is, years ago, certainly when I was a kid, 50, 60 years ago, if you bought something, it came in glass containers, and you paid, like, can't remember, it was a nickel or something for that glass milk bottle. Yeah. And after you were through with it, you took it back to the store and you got your nickel back. Well, I'd love to see us to begin to go to systems where we're doing more, glass return. I have a Duke student, a wonderful young person, and He always takes his containers with him when he goes out to dinner or something. And if he has leftovers, instead of taking a doggy bag, which we know are usually plastic containers of some sort, he has his own that he just takes his leftovers home in. And those are things that it would be somewhat of a societal change, but we probably need to begin to start thinking about.
Working that way. Yeah. That's so many
Yeah.
questions come to mind. I know I can't keep you forever. You
Right.
mentioned, yeah, you mentioned before we got started about a news source that you like to use. I'd love to pull it up and kind of tell the folks, what kind of information. Sorry, that's my.
That's all right. Yeah. And I've only got a minute or two left. I have um, another call coming in. But Jeremy, I think, well, Environmental Health News is a website that has, weekly information on, I see you've got it up there now.
There we go.
Right. Has weekly information on topics of environmental interest that I think is, occasionally the people who run it write their own articles, like this one about Joe Ledoux, but often they're just pulling press articles from that come from the press. If though you're interested in like what are safer kinds of products to use, the Environmental Working Group, I think, has an excellent site that you can use, and the Green Science Policy Institute also. So, for example, if you wanted to get some nonstick pans that didn't have PFAS, you could look on EWG or Green Science Policy Institute website and get names of products which wouldn't have that. So I think that's a helpful place for people to go. Can't hear you again, Jeremy.
Okay.
Your mic. I'm sorry.
I'm gonna have to get a new mic. I don't know what's going on here. This is supposed to be one of the best in the business. Anyway, so I want to respect your time. I know you've got another place to go, but thank you for spending your time with us and informing us about these chemicals that are everywhere and kind of some practical solutions about what we can do to stay healthy.
Well, thanks, Jeremy, and thanks for being involved in this topic.
Thank you very much. I'll talk to you soon.
Okay. Bye-bye now. Stay safe.